Thanks, everyone. So 5 o'clock, Friday afternoon, at the end of an awesome, intense two-day conference. I know you are all desperately waiting for some more PowerPoint slides. I hear you. I hear you. We just had our 3-day Industrial Internet Conference down at Fort Mason, so I hear you. I will not disappoint you. Here we go. I'm going to talk to you about the digital revolution which is coming into industry. And number one, how it's transforming industrial companies. I know you've had a panel earlier on in the conference with my colleague Hima, who's talked about how every company is now becoming partly a digital company. But I want to broaden the horizon a bit and also tell you what is happening across the world and how this revolution will impact jobs, the economy, trade, everything that goes on around us. So what we see here is really a technological revolution which is coming from the merging of three disruptive forces. And let me underscore revolution. As you've seen from my background, I'm an economist. I think what we're seeing now is going to be as big as the industrial revolution we had in the 1800s and 1900s. So in terms of the impact on all of us in the world, it's going to be huge. And it has three components. So we've called the ensemble of this the future of work because it will redefine the way work is done, the way the world operates. The first pillar of this is what we call the industrial internet, which is essentially turning industrial machines, whether they are jet engines, gas turbines, or medical devices in hospitals, turning them into interconnected devices, the equivalent of our smartphones. So devices which can think by themselves, can interact with the environment and with us. And it boils down to an impact of greater efficiency, greater productivity, and therefore greater economic growth. So this really changes the natures of all the industrial objects we interact with. The second pillar, advanced manufacturing, is a combination of different factors. Some of them are different production processes, 3D printing, 4D printing, really new ways of building objects which allow us to build objects which have completely different physical properties. Connected with this, the idea of using different materials, but also the idea of interconnecting, again, digitally, everything that happens on every single factory floor, but also with supply chains and distribution channels. And it boils down to more speed and flexibility. So this really changes the way that we produce things. And the third pillar, the global brain, is crowdsourcing, open source innovation. It transforms the way that we think as an industrial community, as a scientific community, and the way we come together to produce new innovation. And when you see it from the point of view of companies as large as GE, it has some interesting implications that I will get into in a few slides. Now, GE is now redefining itself as a digital industrial company. As background, GE has been around for about 140 years. So it's a pretty old company that has reinvented itself over and over again. But I've been there from the beginning with Thomas Edison, and I can tell you this is by far the biggest transformation that the company is going through in its entire history. And it's focused on this idea of the industrial internet. So what are the drivers of the industrial internet? The first one is the coming together of the physical world of machines and the analytical world. So the meeting of big data and big iron. The second is the one I mentioned earlier, brilliant machines, so the idea of turning industrial machines into interconnected devices. And then having the ability to sift through industrial quantities of data. Now, industrial data has two implications. One is that the quantity of the data coming at you is just gigantic. Just one single jet engine produces 1 terabyte of data in one flight. So you're getting a gigantic amount of data from this industrial equipment. You need to be able to analyze it, to turn the insights into actionable insights, but also you need to do it in a way which is totally secure. So cybersecurity, when you think of machines like jet engines or medical devices or electrical infrastructure becoming interconnected, you can clearly see how cybersecurity is of the utmost importance and cannot be emphasized enough. And the last pillar of the industrial internet is people at work. So how does it change the way in which all of us operate? And all of us is me, it's you, it's the technicians who go out in the field to repair an oil facility or a pipeline. So why are we so excited about this? One is we feel we have to, because if the digital world is coming into industry, the industrial part of GE is huge. Right? We're a gigantic company which is spread across the world, and we have tens of thousands of industrial machines, from locomotives, jet engines, gas turbines, wind turbines, medical devices, and more and more and more things that I cannot fit on this one slide. So we have the installed base of industrial assets. So if the nature of that base of industrial assets changes, we have to get on with the program. So 4 years ago, in 2011, we said, okay, we do need to build up our digital capability. And the first step was setting up a software headquarters here in the Bay Area. We poached the great Bill Rue from Cisco, and we started hiring 250 people. So we started very small. And 4 years ago, nobody really believed that this was just a serious thing happening. 3 years ago, we held our first Minds and Machine conference on the industrial internet, and we had quite a small room down in the close by in the dog patch, which was almost entirely taken over by a jet engine on stage, because we were starting off, we are GE, so we like to do big things. So first we rented a small space and then said, well, we have machines, we have to have a big machine on stage. So here was a gigantic jet engine taking up half the room. But fast forward to 2015, and now we have established a month ago GE Digital as a full-fledged business division within GE. Now, GE Digital now has 14,000 software developers. It has already $5 billion in its own revenues. It covers about 100 countries with 30,000 people working within GE to cover a base of industrial assets, which across these countries is worth about $1 trillion. So within the space of 4 years, it's already become very, very big. Now, you're used working in the software world, you're used at exponential growth. Industry, traditional industry, is not used to seeing exponential growth and exponential transformation. So what we're seeing now is unusual. It's truly transformative. It's a challenge, an exciting challenge, but a challenge for everybody, including companies like ourselves. The next frontier, the next step is with GE Digital, we are now launching Predix, because we've looked around, or mostly having hired now hundreds and a few thousands of people who know what they're doing, you quickly realize that if you're moving to a digital industrial world, then this digital industrial world must have some form of a platform, some sort of an operating system. And the operating system has to be different from the ones that you find around today, because it has to fulfill those functions that I mentioned earlier. So being able to deal with industrial quantities of data in a way which ensures interoperability and cybersecurity. So my colleagues in the software center have been developing the operating system, which is Predix, which is now going to be open. So much as you have on the operating system and platforms for the Apple iPhone or for the Android devices, you're going to have the possibility of developing applications for industry onto this platform. And the idea is exactly to accelerate the process by which digital solutions are being developed, so as to allow the benefits that the industrial internet can bring. Now, what are the benefits? It's actually remarkable once you realize to what extent the performance of and the management of the industrial system so far has been completely uninformed by data. So it has almost completely ignored the availability of data. Think of the way that industrial machines are maintained today. You do it on a fixed schedule. So you have, well, on a fixed schedule or when something goes wrong. So traditionally, if you have to maintain a gas turbine or a jet engine, you either do it every 6 months, every year, or you do it when something goes wrong. Now, the problem is when something goes wrong, that's when you get stuck on the tarmac in an airport for a couple of hours while they try to fix the problem that they've just discovered. It's a waste of time for us. It's a waste of money for the airline. It's a waste of opportunity for the economy as a whole. What happens once you start looking at the data is, unsurprisingly, you understand these machines better. So all of a sudden, you are able to move to predictive maintenance, which means the data will tell you that a specific machine is 80% likely to fail 2 months from now in one specific way. And then you have 2 months of time during which you can plan ahead, decide when you will take it offline, decide how to reorganize the work around it so that you can do the maintenance before you have a failure, and you can continue your production, your service plan without interruption, eliminating unplanned downtime. And then similarly, you can use similar insights to optimize the performance of entire systems of assets. This really has real-life implications on all of us. Think of hospitals. Today, in most hospitals, because of the lack of a software system, people don't know where the equipment is. So you end up wasting time and being able to cure fewer patients simply because you have to hunt around for the equipment. So there are massive gains to be realized through this. But importantly, the idea of developing an operating system for the digital industrial world is to accelerate the growth of these benefits. Mobile platforms and the app economy have been one of the key drivers of fast exponential growth of revenues and value in the consumer internet. And the idea is that once you open up an operating platform for the industrial internet, you will have a similar acceleration of effort with more people coming in to develop applications. And so an exponential growth in solutions and in value in the industrial world as well, which has huge economic implications. And here I'm talking from a purely from an economist perspective of pure commercial value. But when you look at the industrial internet and you ask, so, okay, gas turbines, jet engines, if I look at the global economy, how big is this thing really? Well, once you go through an analysis of how the global economy is made up of the different sectors, you realize that these are solutions that will touch about close to half of the global economy. And with the kind of performance gains that we're already seeing at the micro level, within 10 years, this is going to create a market of a value of about $9 trillion on an annual basis. So within 10 years, this thing is going to be twice as big in terms of value creation as the consumer internet. So both because of the value creation and because it is something that touches all of us, whether it's through transportation, critical infrastructure in electricity, in water, or healthcare, this is going to be where the most exciting action is. Now, how can we be confident that the value will be created? Because you can see it already in the initial examples. So here I've listed just some of the solutions that have already been developed by collecting the data, analyzing them, and then coming up with different ways of doing things. And the value that you create is immediate and it's significant. Let me just mention a few of these. In the case of wind, we have wind farms where the efficiency is extremely important, because if we really want to have a future of sustainable energy, we need to become more efficient at how we generate renewable energy. Now, with data, you can now do something which is both extremely simple but extremely cool. So you have a wind farm with different lines of wind turbines. And what happens as the wind shifts is that now, thanks to software, the turbines can literally talk to each other and adjust the pitch of their blades in a coordinated way, realizing that the way in which the first line of turbines uses the wind will impact how the wind moves on to the second line and then the third line. So what you want to do is for the wind turbines to adjust their blades and adjust the way in which they use the wind so that they maximize the power output as a system, as a team. And that's exactly how they do it, and they do it continuously as the wind shifts. And it results in this case in a 4% increase in energy production in annual output and a 20% increase in profitability. Now, if you think of the importance of making renewable energy economically efficient, this is huge. Similar techniques reduced fuel consumption in railways, in aviation. In aviation, you also find things which are extremely simple. So with data, you realize that, especially in certain parts of the world, you can save money, make the engine more efficient, reduce fuel consumption, and need fewer intervention in maintenance simply by power washing the engine with water at specific intervals. Very simple solution. Nobody had gotten there before we started looking at the data. And then the ability in the health sector, again, to have patients wait for shorter intervals of time, but also having platforms where different medical experts can collaborate and give better solutions in a faster way. Let me now move away from the industrial internet narrowly defined. I mentioned advanced manufacturing at the beginning. So think of everything that I've described so far. You have intelligent interconnected devices. These include everything which sits on a factory floor, every piece of equipment. It also includes, by the way, wearable devices and portable devices for workers of all skill level on the factory floor. It includes digital instruments to connect what is happening on the factory floor to the supply chains and to the distribution. And what happens is you can, first of all, organize the production process much more efficiently. You can become much faster in your cycle of designing new products, prototyping them, and bringing them to market, and then changing them, because now, thanks to data, you have these new production techniques like 3D printing and 4D printing. But this is not just about efficiency. What happens here is you are fundamentally changing the idea of economies of scale. When you start getting your education as an economist, they teach you this concept of economies of scale, which is very powerful, but it boils down to making a big investment in a big industrial plant with huge machinery, and that then pays off by producing thousands and thousands of identical pieces of products. And now with these techniques, you don't need anymore. You can become economically efficient at a much smaller scale, producing not just thousands of identical parts, but producing hundreds of different parts, which you can adapt and switch with extreme speed and flexibility. But if that happens, what that also means is that all of a sudden you can have smaller factories, you can have micro factories, you can become much more flexible in where you go and position them, which means you can create jobs by positioning them where the talent is. Think of areas in the US where unemployment is still high. It also means that in some of the emerging markets around the world, all of a sudden it becomes much easier to start creating a manufacturing sector with smaller factories that can create good jobs, and which are the only way to accelerate the process of economic development and convergence, of bringing up living standards in emerging markets towards advanced economies. So from the point of view of the potential economic impact, it's huge, but also from the point of view of the disruption, it is huge, because it means that when we, at GE, we are a huge company, when we look at this, we also think, okay, so our traditional advantage of being a huge company is not going to be the same it was before. So we also need to change the way we operate. We need to become faster, but we also need to become more open. So we have switched to focusing a lot more on alliances and partnerships with partners, with people and companies, small and big, which bring something to the table that we do not have. So we have a venture operation here near Stanford, which is exactly focused on cooperating with startups which operate in our same fields of actions. And finally, the other way in which we have opened ourselves up is by using crowdsourcing. Now, this is one example of something we did 2 years ago. GE has always been very proud of doing innovation in-house. We think we have the best people, we're very proud, and we do have most of the best people, but clearly not all of them, because 2 years ago, after internal discussions, we said, okay, this crowdsourcing thing, everybody's so excited, why don't we try it? Let's give it a try, on a small scale. So we took one simple component, to the extent that anything related to a jet engine can be simple. It's a jet engine bracket. So it's a piece of metal that attaches the jet engine to the body of the plane. Relatively simple, pretty important. We put the design on GrabCAD, and we issued a challenge saying, OK, this is the design we're using now. We challenge you to give us a design which should be produced with 3D printing. It should be at least as strong, and it has to be lighter, because you have to reduce the weight of the parts of a plane to reduce fuel consumption. We had a number of high-quality suggestions and submissions, and the winning design came from a young engineer in Indonesia, somebody who had zero background in aviation or jet engines, none whatsoever. Gave us a design which is stronger, producible with 3D printing, and is 80% lighter than what we had. And when our aviation engineers who spend their life in the sector looked at it, of course, they first said, it cannot be. 80% lighter, it cannot be. There has to be something wrong with the design. And we said, please take a closer look. They took a closer look. That is the design we now use. Now, think of the implications of this. As an economist, to me, it's almost intuitively obvious in the sense that if you open up the problem to a wider set of resources, you will get to a better solution faster. That's intuitively obvious. But it also means that the value of tapping the expertise of people who have a completely different background is enormous. Giving people different incentives is important, because an engineer within GE would have been scared of producing a stupid idea. Your career is shot. If you are at the outside, you have nothing to lose. So then you say, OK, if it's so powerful, shouldn't we do it on a bigger scale? And the answer is yes, but that forces you to think more carefully about what do you do in terms of intellectual property, how do you reward people, and how do you move towards a world where the workforce will probably be organized on a much more flexible scale, giving a lot more opportunities. So in conclusion, 2 words about this. The combination of digital and industrial is going to be the biggest change we will see in our lifetimes. It is huge. There is a lot of fear out there. When I go to conferences outside of the tech world, I get hit with a whole lot of technophobia of people saying this is just going to create poverty. It will get people out of work. It will increase income inequality. It's nonsense, because it's through innovations like this that we will be able to create more jobs in emerging market countries, and that we will be able to give more skills, more powers to workers at every skill of the distribution. But it's going to be a hard slog in terms of both getting it done and in terms of persuading people that it is happening. But this is the time when this really accelerates, takes hold, it accelerates, and it starts to develop and bring value and show its impact in a way that we've never seen before. So with this, I hope you will be much more excited about thinking the industrial part of the digital industrial, but it's really the coming together of the two, which will become inextricably linked, and it will change the world. So thank you very much, and enjoy the weekend.